Assalamualaikum warahmatullahi wabarakatuh. We are from Group 17. We want to present about AM modulation by using optic system software. My name is FAIRUS ASMAYANTI.
My name is AMALINNA.
My name is NURUL binti Khairuddin.
My name is AWATIF binti Muhammad.
And my name is ISHMAH SABIRAH binti Syarif. So enjoy our video.
Assalamualaikum and hi. So, we will start with the introduction. OWC or optical wireless communication have two types, which is indoor and outdoor, but we will focus on indoor parts. OWC enables wireless connectivity using infrared, visible, or ultraviolet bands. It consists of two operations which invisible bands. The operation is visible light communication, VLC, or infrared, IR. IR typically use laser transmitter. Also, offer a cost-effective protocol transparent link with high data rates. OWC systems operate in VLC system good in light-emitting diodes LED, which can be pulsed at very high speed without noticeable effect on the lighting output and human eyes. The process of mounting original signal to a carrier wave are called as modulation. The amplitude modulation, or easily short as AM, commonly used in broadcasting radio signals, which it involves in alteration amplitude of the carrier wave, where the amplitude of carrier wave is varies proportionally according to the input signals. It has a low quality of sound but can travel over a long distance. Modulation takes place in two stages. First one is transmit information is coded as waveform, then the waveform modulate a signal intensity in terms of amplitude of emit infrared light.
Next, for the objective, we have three objectives. The first one is to design an indoor OWC link based on parameters given using amplitude modulation techniques. The parameters involved is transmission distance, transmitted power, wavelength, transmitter diameter angle, receiver responsivity, and receiver diameter aperture. Number 2 is to evaluate the performance characterization of amplitude modulation using optical modulator and electrical modulator in terms of Burr analysis, I diagram, and Q factor. The objective on number 3 is to analyze the performance characterization of amplitude modulation system by using optical modulator and electrical modulator in terms of Burr analysis, I diagram, and Q factor.
This is a simulation designed for amplitude modulation. In this simulation, we state three simulations, which is without modulator, electrical modulator, and optical modulator. First, without modulator. In without modulator, we use pseudo-random bit sequence generator, RZ pulse generator, oscilloscope visualizer, MZ modulator analytical, FSO channel, pin photodiode, low pass Bessel filter, 3R generator, and Burr analyzer. The function of pseudo-random bit sequence generator is to transmit information in a binary pulse. Function of RZ pulse generator is to create a sequence of return to zero pulses caused by an input digital signals. Then the signal will send to the oscilloscope visualizer and MZ modulator. In oscilloscope visualizer, the signal will display, and in MZ modulator, it will control the amplitude of an optical wave. The function of FSO channel is to propagate medium for the transmitted light. And the function of thin photodiode that used in this simulation is the signal will generate by a thermal and a short noise. Then we use low pass Bessel filter to reduce the noise. After that, we use 3R generator to simplify the connection or to simplify the complex system. Then the function of Bird analyzer is to find the Bird and Q factor of the signal. For electrical modulator, it's same as without modulator, but we just added electrical amplitude modulator. Okay, next is a optical modulator. The design of optical modulator same as a without modulator, but we remove MZ modulator and change it with a amplitude modulator.
Okay, now I will continue about how the simulation work. Firstly, as we know, the optical communication system consists of a transmitter, transmission channel and receiver. Then the transmitter consists of a continuous wave laser, CW, pseudo random bit sequence generator, PRBS, return zero pulse modulation generator and modulator. Next, for the receiver side consists a pin photodiode. The input signal has been generated by the return zero RZ pseudo random binary sequence in a simulation setup. And for the input signal is modulated with continuous wave laser, CW, through with or without amplitude modulator MZ. The input signal also is supplied by continuous laser with 780 nanometer wavelength at power 100 milliwatt, which is vastly modulated and with a different modulation format in amplitude modulator that are optical and electrical modulator. The modulation index 0.5 has been applied to amplitude modulator MZ. In this optical communication system, the amplified signal will pass through low pass Bessel optical filter. Therefore, properties of the Bessel optical filter are cut off frequency by 0.75 multiplied by symbol rate. That's all. Okay, for the simulation result, I will explain the without modulator of the simulation. We were using for parameter sweep 3 at 2 meter. As we can see, the Bird analyzer of Q factor, minimum bit error rate, threshold, height and Bird pattern was measured in this simulation result.
Next is an electrical modulator for simulation result. Currently, we choose sweep 3 at 2 meter. As you can see here, this is a Bird analyzer diagram for Q factor, mean Bird, threshold and height. And for the blue line is the eye diagram of the electrical modulator.
Next, this is optical modulator. Same as previous, we choose sweep 3 at 2 meter. By using Bird analyzer, we analyze Q factor, Bird mean, threshold and height. Next, for analysis data. The figure shows the input variation of Q factor versus distance. For without modulator, the higher value of Q factor at 2 meter while the lower value at 0 meter. Next, for optical modulator, the higher value of Q factor at 2 meter while the lower value at 0 meter. Lastly, for optical modulator, the higher value of Q factor at 3 meter while for the lower value at 0 meter.
For discussion, an optic system software was used to analyze and evaluate the performance characterization of the system for AM modulation format using general, without modulator, optical modulator, and electrical modulator in terms of Burr analysis, I diagram, and Q factor. For Burr pattern, refer to the Burr figure versus bit period time, and height refer to the eye opening in the eye pattern, which shows the quality of the signal. The more the eye opening, the less the error, and therefore the better system performance achieved.
For conclusion, amplitude modulation is a simple technique often requires very low-cost hardware. There are two basic types of AM technique, which is baseband and RF carrier. Based on this assignment, it was known how to design the AM system based on parameters given using Optical software, and it also known how to evaluate and analyze the performance characterization of AM using optical modulator and electrical modulator in terms of Burr analysis, I diagram, and Q factor.
That's all from us. Thank you for